So this is all about virtual twin experiences powered by AI. So to take us through, first up, we have someone who's responsible for all the aspects of the brand strategy, portfolio, and business operations at Dassault Systèmes, and he comes with over 20 years of experience in AI, big data, and digital transformation. Ladies and gentlemen, it's time to invite our next speaker on stage. We have with us none other than Morgan Zimmermann, CEO, Netvibes, Dassault Systèmes. Can we have a huge round of applause, everyone?
So today, we are going to continue to discuss about AI in the context of sourcing. It's not the first time within the day that we talk about sourcing. And I thought I would take a few minutes to tell you why. Because you know what? When we talk about sourcing, in many cases, people start thinking that this is an ERP topic. Because people believe that when it comes to sourcing, it's all about optimizing and automating, you know, all of the procure-to-pay process and the transactional aspects that goes along with the sourcing and procurement process. That's not at all what we are interested in. What we are interested in is the source-to-contract process. Because we believe that 70% of the opportunity, whether for cost savings, or for sustainability improvement, or for efficiency improvement, is coming from the source-to-contract process. And that is related to how quick and how smart is the collaboration interaction between engineering and procurement, because this is where the decisions are happening. And by the way, there are no automation technologies so far that can solve that problem. At the design stage, how do I select the most relevant part and the most relevant supplier? And there are many problems that need to be solved. I highlight a few of them, but I'll start by one, which is a language problem. Even when we work, you know, with new startups in the EV market, you know, after a few weeks, if we start to look at what they do, the same part may have different names. You know, a bracket can be called a holder or a latch or a plate or a mounting plate, you know, or whatever. That's in a small startup company. Think about it when it comes to multinational that made many acquisitions, that have people speaking many different languages. It quickly becomes a mess. And I've seen many companies that are managing millions of parts that can sometimes be the exactly same part with different part number, with different price, and so on. So to solve that problem, we have implemented new AI technology, which is not anymore working on the language itself, but it's working on the function and the shape. Take millions of parts, use artificial intelligence to automatically identify all of the parts that have the same shape, the same function, even if they don't have the same name, and then make sure you drive the process from here. You'll see that in action in some of our processes. I wanted to tell you what we do in sourcing for source-to-contract. At Dassault Systèmes, we are covering all of the area for source-to-contract, which starts for market trend. Can we understand what are the new startups, what are the new supply chain risks, what are the opportunities that we can see on the market? With that, we are feeding the sourcing strategy definition. Can we define how we want to organize commodity groups? Can we define how we want to set up the tier 1, tier 2, tier 3 supply chains? Then we go into standard and diversity management powered by AI, and you will see some very tangible example of that later today. We will go into many details. We go then into cost, and when we speak about cost, we speak about a few things. We speak about, can we define the targets for a given product? At the product level, at the system level, at the part level? Can we measure through the development cycles if we are converging on or diverging on that cost? Can we do the trade-off and the risk and opportunity management for cost? And then, of course, that goes into the deep interaction with the suppliers. You've seen that this morning with the Mahindra presentation. Can we automate the sending of the RFX? And can we facilitate the interaction with the suppliers without ever exchanging an email, an Excel spreadsheet, or a PowerPoint? And then, of course, going into quality and volumes. But rather than words, let me put some images. On this example, what you're going to see is you're going to see a company that is having millions of parts coming from many acquisitions. The component engineer here is starting with some of our AI technology that allows to take all of these millions of parts, which can be multi-CAD, multi-source, coming from our competitions or from whatever systems, and it's automatically helping to regroup these parts into classes. It's automatically allowing to cluster these parts in the right class and propagate it into the right class, and then, within a given class, select what are the preferred parts or the standard parts that we want to deploy. But this is only useful if it can be used by the designer. Here you have a designer in X design, and finding out if there is any preferred part, here for a blade, is as simple as a right click. Can I have a similar part existing somewhere in the company? If there is a preferred part, let's use it. If there is no preferred parts, we can automatically bring in some of the 70 million parts we could capture, which are buy parts from catalogs. That could be an interesting alternative. But what comes interesting is the NPI process, because that's about introducing a new part. So the NPI process is fully automated here. There is no administrative work that is done for the engineer. Everything is pre-completed by assembling the data and promoting that request for new part introduction to the component engineer. But the component engineer, he has the right to check. Check whether there is not an existing part for that request. Check whether there is not any more relevant suppliers that should be contacted. And for the same reason, the component engineer is guided against with AI. It will be suggested alternative suppliers and alternative parts that have the right fit for purpose. And he can complete the list of the components that need to be looked at. Or by the way, he may decide that we should definitely reuse one of the existing blades. When this is done, that gets promoted to procurement person. The procurement guy, within few clicks, he can transform the request into call for tenders, provide the volumes, and send that to the suppliers that can then online complete the request and start exchanging, with engineering. What's important in what I'm showing you now, it's not what you see, it's what you don't see. You don't see any Excel spreadsheet. You don't see any emails. You don't see any PowerPoints. All of that is digitally continuous. Then comes the negotiation phase, which is my preferred one. It's how do you empower with artificial intelligence the procurement person so he can drive negotiation? How we can take a design, automatically identify in the past if we have sourced anything similar, automatically identify within these similar things we have sourced, what were the cost drivers, what were the cost inductors, what were the price points, and use that to drive the negotiation down. And as soon as this is done, this is made available to the designer, once again, without emails. What's interesting in this example is you're seeing a company where we've captured data which are coming from many different systems, from ERP for cost to many PLMs, many CAD systems. We have made all of that data available by projecting on virtual twin experience. We have connected procurement, engineering, costing, designers through a lean business collaboration methods. And the whole of that assisted by AI and without ever exchanging emails, so everything is digitally traceable. The reason why we think it's important, it's because there is deep money on the table here. What we have seen with many of our customers is that there is in between 5 and 15% of the total commodity spending that can be saved just by stopping buying multiple times the same thing. 5 to 15%. So of course, it's probably more 15% in aerospace and more 5% in automotive. But that's the reality. And when you think about how many billions of euros you spend in procuring every year, I let you compute how much money sits on the table that can be saved with the right application of AI. To go further into that, I would like to invite Sreekumar PANICKER from EATON. Sreekumar is the VP of Global Supply Chain at EATON, but he has a very interesting profile. Please come in, Sreekumar. He has a very interesting profile. Before becoming the VP of Global Supply Chain, he was VP of Engineering. And this is quite interesting. That's a new trend. It's this new generation of supply chain person that are not coming from the ERP side of the negotiation, is coming from the engineering side, because this is where the opportunity lies. Sreekumar, can you tell us more about EATON and what you've been doing in that space?
Good afternoon, everyone. Thank you, Morgan and senior leadership team for inviting me and EATON into this particular conference. I think very relevant topics that we discussed today. I think a lot of good presentations, good topic discussion, especially on sustainability, especially on digital twins or virtual twins, collaborations, innovation. I think it's a common topic of interest, right? Before I present few of the use cases that we have used, how we have used the collaborative between engineering and supply chain, I want to just introduce EATON because I don't know how many of you know EATON. Probably many of you know EATON as an automotive supplier, but I think we are bigger than that, and the complexity that we have today is much higher. So EATON is a 100-year-old company. I think we started off in automotive, established in 2011, and we are present in about 170 countries with $20 billion of revenue last year. And we are primarily an intelligent power management company. What it means is that we are not in the business of generating power, not in the consumption of the power, but we are in the distribution, which is primarily between the generation and the consumption side. So we have a lot of products that actually goes into different applications, like in automotive. As an example, transmission, which engine and between engine and the wheels, right? Or you talk about electrical, all the power distribution, the switch gears, right? So we are a intelligent power management company, basically helping to improve the quality of life. And our team is also around protecting the environment. We have a huge 2030 goal for sustainability because we are the manufacturing footprint, lot of large manufacturing footprint. And our growth is actually driven by two main factors, globally as well as, you see the same trend in India. One is around electrification. You look at number of EV vehicles that are coming in North America as well as in Europe, and India is catching up, right? I think whether it's a two-wheeler, four-wheeler, the number of EV vehicles on the road is going significantly high. And what does it create is it creates a bigger challenge of power infrastructure, meaning that we have to modernize our grid in order to support all the EV vehicles and the charging stations, right? So it's a great opportunity for EATON because we are into that particular business. Second one is about digitization. I'm going to talk about few of the examples how digitalization has helped in terms of improving our efficiency and the collaboration that we had between engineering and supply chain. Of course, regards to sustainability, we actually have three different topics, even though it is not listed here. Our sustainability goals are around three different topics. One is about actually declaring in terms of what is our, the green gas current state. So we actually follow very rigorously in terms of making sure that it is transparent to our investors, transparent to our customers. Okay. The second one is about how do you work with customers to improve the entire life cycle of sustainability, not just only from the product, but even from manufacturing to finally when the product gets into sunset. And I think third one is we have a large manufacturing footprint. So how do our operations we can actually reduce significant carbon impact. So that's how we are focused on sustainability is a huge goal, and this topic is pretty much relevant for us. So our business actually spans into two major industries. One is we call industrial sector, which is primarily into aerospace, automotive. Now we have formed a new business called e-mobility, which is basically catering to all the EV, primarily focused on power distribution and protection. So meaning that we have a lot of products even that goes in terms of protecting even the battery fuses. Okay. Similarly, on the aerospace side, we are into fuel pumps, fuel systems, and conveyance, which is where the entire power is getting distributed across the aircraft. Similarly, on the e-mobility side, again, we have motor control systems. We are into inverters. And electrical is a very large business which is spanning across right from the grid all the way to distribution centers. To a building like this is heavily powered by a lot of protection and power distribution systems. So we are into that business in terms of power distribution, circuit protection. We are also into data center in terms of large UPS, data power quality and energy storage. Buildings like this in terms of life safety, we have a lot of products which actually both for lighting as well as for ensuring that safety is ensured. structural solution. So if you look at cabling solution, typically for a building, we are there in terms of the entire structural solution for cables. Control and automation primarily aimed at, in manufacturing areas. And the hazard and harsh and hazard locations specifically for oil and gas, we have products which are designed for that to meet that specification. So it's a very diverse portfolio, so you can understand the challenges that we have typically in terms of product design and manufacturing. Okay, so we are working very closely more than a decade with with Dassault Systems and 3D Experience, and we use many of their technology in our product design and as well as in terms of supply chain management. So I want to take one use case and maybe talk about it, how we actually benefited us. Before I go to this, since Morgan introduced me saying that I came from engineering. So I worked in engineering for almost like 30 years. And about 4 months back, I moved to supply chain. And primary reason for that is we know engineers are very eager to design against the spec, right? But when it comes to launch, when it comes to manufacturing, is the product really being able to manufacture? Is it really able to design for supply chain? So many times we have found a challenge because engineers are not focused around that. And the supply chain team says, anyway, they don't listen to us, so let's focus on the current problem rather than the new product development. So one of the reasons why I moved in is primarily to bridge that gap in terms of how we can resolve the issues or how we can enable collaboration between engineering and supply chain to really solve larger problems. So this example is one such. There are many initiatives that we are running, okay? So where we have used, one part from 3D Experience, really to collaborate and say how we can benefit. So if you look at, we started somewhere in 2019, we realized that EATON is a huge organization. We have grown by acquisition. There are a lot of, ERP, MRP, and, system that actually comes in our systems. So it's a huge challenge that we have. So we started in 2019 with a POC, and then you can see the number of licensed users that we have over a period of time that established. So you can see currently we have around 4,600 users between supply chain and engineering. And if you look at on the chart, you see that 42% of them are actually supply chain and 46% of them are users from the engineering side. So one of the important things is we established this foundational work in making sure that all our parts are inside one part. So just to give you an idea, we have close to about 12.5 million parts inside our system, which is a huge one. I think it's not about 1 million, no 2 million, but close to 12.5, which covers probably about 80% of our parts that we source. Okay? One of the important challenges that also we have, I mean, probably everybody has the same challenge, is that data quality. We can have 12.5 million parts, but if there is no specification, there is no drawing attached, there is no 3D, it's not complete for sourcing, right? So if you look at our data quality, it is still about less than 20%. And I think the problem that we have come to that level is because of a lot of legacy products. So we are trying to improve the legacy and also ensure that whenever you are introducing a new part or a new product, we are not duplicating these issues. Okay? So I hope you understand the scope and the challenges that we have when you look at such a large organization. So how one part has helped us? I have 3 use cases. We know this is not the only examples. I just picked 3. There are many examples in EATON, but primarily to just give you an idea about how we can actually, how it has helped us in really saving our, in one particular case is more about, the cost out. So we have a part that actually used to make our transmission, or clutch, for example, it's a lot of components like washers and spring. And we found using one part, which is more AI-based, and we can actually search part by, either by the part information or the specification, or by a 3D drawing, or by 2D drawings. So we are able to finalize, or we are able to find that we could actually rationalize the same parts that exist already in our, maybe in another division, and reuse that, and we were able to result about 150K of savings by using the same part. Okay? We are not stopping here. We are now extending this to engineering, saying that whenever you are designing a new part, we have to first search our existing database of one part to ensure that we are not introducing any more complexity, or we are reusing those parts. So in that way, we are able to significantly save our time, save money, as well as save time to drive efficiency. This is one such use case. The second one is mainly in terms of how we can resolve supplier escalations. So we found that in one such use case, we are not able to find a part from the supplier in terms of one electronic part, which is basically around digital potentiometer. And when we searched the one part, we found a nearest matching part, not exactly, but nearest matching part, which could actually be substituted and could work for that particular product. Okay? That has actually saved weeks of time and resolved any kind of supplier escalation that we had, and really helped in terms of helping our lead time and making sure that we are able to deliver those products back to our customers. And sales risk of roughly about 12 million is where we mitigated with this particular use case. The last one is about, we are also using this tool, as Morgan talked about collaboration and innovation, right? So we are now looking at more of a network to really look at globally how we can reduce the part complexity and kind of reuse. We did a workshop to really look at globally different regions and see how we can identify similar parts, how we can use suppliers who are situated across the regions and identify, and probably there is opportunity to negotiate even for the same region, because we know those parts are utilized across. So with that, roughly about 500K of cost out opportunities have been identified. So again, it is now a part of daily use by our engineers, by our supply chain team, and our manufacturing team to really come out with significant impact to our daily operations and ensuring that we are making more progress towards creating productivity or creating efficiency in the systems. I think that's all I had, Morgan.
Thank you very much. Thank you very much. 12 million parts. You're one of our biggest customers in volumes. We have many customers that have 1, 2, 3 million parts. 12 million, it's a lot. But when you think about it, 12 million parts, it's an incredible IP. It's the history of your company.
Absolutely.
It's the intellectual property of your company. And what sits in behind this conversation is, how can we transform that intellectual property into an asset for constructing the future, into an asset for empowering engineering and procurement communities. And at this scale, the levers are massive. I think we have 2 minutes to take questions. Should there be questions? Okay. No questions. I think it was very clear. Thank you very much, Sreekumar.
Thank you very much.
That was very clear.
Thank you.